Hello! In this video, we'll be going through section 1.1, graphs. Specifically, we'll be looking at a couple problems that include some equations, and we will be creating graphs out of those. So, in problem 1 here, we are tasked to find solutions to the equation 3x minus 4y equals 12, and to use the points that we find to graph the linear equation. We have a couple hints here to keep in mind. We are told at the bottom here that every point on the line is a solution to 3x minus 4y equals 12, and also that every point on the line makes the equation a true statement. What this tells us is that we are going to be using that equation and trying to find these coordinate points based on what values would work to make that equation true. We are given a table on the left side here that include a few x coordinates. We see -4, we see 0, and we see 4. So, if those are our x coordinates, I'm going to plug those in to that equation there and solve for y to find a coordinate pair, x, y, that I can then graph. So, for example, with -4, I'm going to take that equation of 3x minus 4y equals 12, and I'm going to plug in -4 in place of x. So that would be 3 times -4 minus 4y equals 12. 3 times -4 will give me -12 overall. And then in order to solve for y, I need to get it by itself. I will first do so by adding 12 to both sides. That will then give me -4y is equal to 12 plus 12 is 24. And then lastly, I can get y completely by itself by dividing -4 on both the left and the right. -4y divided by -4 will just give you y. And 24 divided by 4 is 6, but 24 divided by -4, it would be -6. This would be the y coordinate that I would pair with x, so I'll go ahead and put that in the table on the left side, and this will represent my first point, -4 and -6. To graph that, I'll go 4 back on the x-axis, like so, and then I'll go down 6 on the y-axis. So down that distance will give me a point about here. This would be -4, -6. Next, I can see what would happen if I plug in 0. To do that, what I could do is go back to my work on the right side and replace where I had plugged in -4 for x, I can put 0 in place of that instead and see what would happen. This one's probably going to be a little bit nicer because 3 times 0 is actually just going to give us 0. Right there. 0 minus 4y is just -4y. And then I would have to divide by -4 again. But now I would have -4y equals 12, and that would have to divide by -4. And 12 divided by -4 this time is going to be -3. So now I have that coordinate to plot, 0 and -3. 0 on the x-coordinate would mean do not move horizontally at all, but -3 on the y-coordinate would mean move down a distance of 3. So that would put a point about here. I can then also do the same thing by plugging in one more value here. We can then plug in +4. If we plug +4 into this equation and solve for y, 3 times 4 is 12. So I would get 12 minus 4y equals 12. I would then get -4y by itself by subtracting 12. And would you look at that? On the right side there, we will get 12 minus 12, which will overall give me 0. And lastly, to get y by itself, I would divide by -4. 0 divided by -4 is just 0. So that gives me a third point to plot. 4, 0 would mean go 4 horizontally. So go 4 in the x direction, and 0 for y would mean do not move vertically at all. So we would just be on the x-axis itself here at 4, 0. I can connect these points here and I can create my line. Just like that. And this should be good. You will notice though that on this problem there are extra slots in the table. This is for if you would like to plug in other x coordinates of your choosing. So for example, let's say I want to plug in x equals -1. I would put -1 here in the table as that would be a number between -4 and 0. So that would make some nice logical sense there. And we could see what would happen. Let me change my work on the side here for plugging in -1. If I plug in -1 for x instead, I will get 3 times -1, which is -3. To get -4y by itself, we would then have to add 3. That will give me 15. Right there. And then 15 divided by -4. 15 divided by -4 is actually not going to give you a very nice value, so if you need to use a calculator to find the decimal approximation for that, 15 divided by -4 should give you 3.75. If we try to graph that, we can check that out. -1 would mean go back 1 on the x-axis, and then -3.75 would mean go down 3 and about 3/4 of the way to -4. So that would give me a point about here, which should exist on the line that we already have graphed. Let's look at one more problem. This will concern a different equation. This asks, is the point -6, -20 a solution for the equation -5x plus 2y equals -10? Well, as a reminder, we have this note right above that problem that says that every point on the line makes the equation a true statement. So if we're asking if this point is a solution to the equation or makes this equation true, then that means if we were to plug that point into this equation for x and y respectively, then this should give us a true statement. So let's try that. So again, our ordered pair here, -6 is our x coordinate, -20 is our y coordinate. If we plug each of those in, I would have -5 multiplied by our x coordinate, which would be -6. And then plus 2, which will be multiplied by our y coordinate of -20. And we're going to check to see if this does indeed equal -10. If I solve that out, -5 times -6 will give us a positive 30. 2 times -20 is -40, so that would be -40. And if I look at that, 30 minus 40, that indeed does give us -10. So that means that this point, this pair of x and y coordinates, is a solution to the equation and therefore would also be a point on this line. So my final answer for this is yes. To wrap this up, let's look at a few definitions. Some of the points that we had plotted on the graph at the top here do have special names. I'll point these out. Notice this green point that I have here that we got from 4, 0, and this blue point that we have here from 0, -3. These 2 points are intersecting or going through the axes x and y, respectively. The green point is going through the x-axis and the blue point is going through the y-axis. Because of that, these points are going to be called x and y intercepts. The y-intercept of a linear equation is the point on the graph where the line intersects the vertical y-axis, whereas the x-intercept of the linear equation is the point on the graph of the line where it intersects the horizontal x-axis. These are very important to understand in a lot of contextual cases, as they very often can give you a starting point when you're trying to compare independent and dependent variables against each other, so they're very important to understand and identify. Furthermore, they also tend to be some of the easier points to plot when you're creating a graph, as if you are intersecting the y-axis, that means your x-coordinates would be 0 there. If you're intercepting the x-axis, that means your y-coordinate would be 0. This is very helpful because if you plug in x equals 0 or y equals 0 into whatever equation you're working on, that very often is a simple value to work with and solve. I hope this helped you understand some of these problems concerning graphing. Have a nice day.